Hello and welcome to the channel, which is going to be another set of disembodied hands soldering together outdated technology. Now on to today's topic. Seeing the HDD clicker on LGR reminded me that I had started something similar to create drive sounds for a Gotek drive. Of course I couldn't get it to work, but the realization was that adapting it for IDE could be done as easy as that, which made me want to revisit the project today. So here it is, the one I made, except 10 times more expensive and significantly larger than it actually needs to be. Basing it on AliExpress MP3 player modules as well as on Arduino Nano. As you can see, it was built to slot onto the common compact flash adapter, though it can happily sit somewhere on the cable instead. As you can see, this is already an existing unit, but it's an old revision, so they filmed the process of building another one, but since things have gone expensive lately, let's just start by breaking it down for parts first. And we're done, so let's build another one. With the components out of the way, we can see the board a bit clearer. The first thing we're going to concentrate on is the pin headers to the left. You have two sets of them. They're designed as pass-through. There's a line dividing the different sections for either the 34-pin floppy or the 40-pin IDE. Today we're building the IDE version, so we'll be using the entire row. The second thing we're going to look at is these pin headers. They're described on the board. We don't need to look at the drive selects because that's only for floppy, but we need to set the mode select according to what we're going to use the board with. In this case, IDE. Note that we need to look at which of the pins are pins 1. Usually it's a different shape. In this case it's the square pins on the SMD pads. For the later revisions with some through-hole jumpers, the pin 1 is also square. Adding the single resistor using the handy tool for shaping them, which made producing them a lot easier. The single diode also needs to be added. This is mainly just used so that you can update the device without having the USB connection attempting to power your computer through it, something it will never be able to do. The polarity needs to be correct. As you can see, there's a silver stripe on the component itself, and the stripe needs to be matched up with the indication on the PCB itself. You have the option of adding a standard floppy drive power connector to the board, but since I'm using this directly on top of a compact flash adapter, I'll instead be using a cable soldered directly to the adapter. You can install a small passive speaker directly on the board, but because I found these handy motherboard speakers in a 10-pack on AliExpress, I'll be using those instead. To attach the speaker to the board, I'm just using some regular right angle pin headers. For the speaker itself, just make sure that you get the passive kind, not the active buzzers. Those only make a single annoying sound, which is probably not what you want. As the board is supposed to slot on to a compact flash adapter, I'll be using some dual row female pin headers on the underside of the board. While I didn't want to order various sizes of everything, I just ordered some 2x40 pin connectors that I'll be stripping away some unused pins and then cutting it down to size. It'll work the same. As the female pin headers need to match the alignment of the board underneath, we'll start by soldering a single pin, then reheat and adjust as needed until it looks roughly correct. With that done, we'll just solder in place the remaining connections. Of course, with that done, we also need a place to plug in the standard IDE cable going to the motherboard itself. For that, we'll just be using these dual row straight pin headers. Just cut them down to size so they match. Ideally, we could use these 40 pin IDC connectors that provide a keying for the cable, but for the cheap option we'll just use the pin headers. Note that for IDE there's a pin that needs to be removed. On the board itself there's a circle around the pin that needs to be removed. Just ensure that you get the right one. For attaching the Arduino, I'll also be using some female pin headers. These are 40 pin as well, but single row. We'll just count out the pins, mark the one that's extra, and then use the space created to cut them into suitable segments. We'll also need to do the same for the MP3 module, so let's just cut off some suitable segments for that as well. With all of those cut down to size, we'll just get started on soldering those to the board itself. The headers themselves don't make good contacts if they're soldered at an angle, so again we'll just solder a single pin, then adjust so that it looks fairly correct. Just test against the module itself if you're unsure about it. This PCB has a single button for testing the functionality of the board. It's just a simple way of having it make some noise so that you know it's alive. Later revisions will also add two buttons for controlling the volume level without having to resort to the serial interface. The button only goes in one way, so just tack it into place. If you were following the assembly process directly, you'll remember that we skipped installing the passive speaker simply because I wanted an external one that they can place anywhere in the computer. The other part that is missing is the power connector, but we opted to skip that one in order to just solder a wire directly to the computer flash adapter. We'll join the two boards together directly now. Just make sure that when looking directly at the connector, it's possible to offset the position by one pin, which is something you don't actually want to do. In order to ensure that the two boards don't separate over time, I'll be fixing those together using some screws and nuts. These are roughly 20 mm long. When fixing them, just make sure that you don't over tighten them, because you'll easily warp the board. Back to the power section. The floppy connector includes 5V and 12V, of which we'll only be using the 5V as well as the connection to ground. The markings on the PCB show you which ones to connect. Note that the 12V will happily kill both of your adapters, so pick the right one and double check it. almost done, so let's just get the modules installed. The first one is the Arduino Nano. We want to match it so that the USB connector is at the bottom of the PCB. The MP3 module has a little cutout that should be towards the bottom of the PCB, while the SD card slot itself should be pointing towards the upper side of the PCB. Okay, so let's just attach the little speaker module, and we're ready to make some noise. As my Arduino Nano already has the sketch installed, I'll be applying some power and we'll see if it works. As the card isn't actually installed in a computer, there may be some false triggering while it's unconnected, but that's normal. Okay, then again, let's get it over to the other side of my dark little workshop and see if it works. Today's test bench is an early Pentium system with a conversion for using ATX power supplies. It's installed in the bottom row. I've already prepared the system with DOS on the comp flash adapter. Ribbon cable has been attached to the board, matching pin 1 with the red stripe on the cable. Power is also connected. So let's just boot it up and see what happens. Booted up first try, so let's just run ScanDisk so we get some more noise. And that's all that needed to be said for this time. Bye.